All right, today we're gonna code up the optimal solution for this problem. Okay, let me reset. Okay, we're gonna do a fresh start. Um, so plan, implement. We have understood the problem, so I will not talk about it again. Please watch the previous video. I need more view. So, let's see. So we learned that we need to maintain two heap, two heaps, one mean heap to keep track of the big number, one max heap to keep track of small number. And there's a few cases to handle. So case number one, uh, empty, empty, two heap, two heap, two heaps are empty. Two each are empty. Doesn't matter which one we put into. Maybe just do mean. You, uh, when, so when count, when the heap one land, when the small heap land is larger. Wait, we have to establish the rule, right? If the number is bigger than is smaller than top element of the big heap, put it in the small heap. So case 2. Probably wouldn't be accurate to call them cases, but okay, whatever. Uh, what happened when you request mean? What happened when you request the mean? When length of the small heap equal length of the big heap. return laying up the small heap and laying up the big heap. Hmm. Try, try this. Uh, when the two are equal, return the average up head to head. Okay. Request median. So case number one, case number two, request median when length up small heap larger than length max heap return one return top of small heap. Uh, rule another rule. If land up big heap smaller larger than land up small heap, the top up big heap give to small heap. So we're trying to make sure that the median values are bound between two heads of the big heap and the small heap. The big heap is going to be implemented with a min heap so that the smallest element is always the element that's near like larger than the median, and then immediate larger than the median, and then the small heap gonna be implemented using a max heap. So implement using a max heap so that the largest number that's just right below the median is also on the top. This is how we're supposed to bound them. Okay. Big H, small h. Guess I should just write big heap. That's easier to read. Hope I don't shoot myself in the foot. Maintain two heap. So to implement min heap, we don't need to do much, but implement max heap. Have to insert number as negative and flip sign before use. Pa 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 pa. Add number. Okay. Let's see. If len of big small heap equals 0. Small heap heap push. Uh, Subtract num. Okay, easy. Uh, elif len big heap. All right, good enough. Else, let's see. Uh, Checking if num larger than dot 0. Subtract or small heap dot 0. If num smaller than top, larger than the top of small heap, put it to the big heap. Big heap num. Else, put it to the small heap. If big heap, if len big heap is ever bigger than len small heap, uh, heap heap push. I love writing nested statement. They are very error prone and very fun to write. Subtract, okay. Forget to subtract here too. Whenever you call this one, I will check. Oh, okay. That should be it. I'm a brilliant developer. I can remember every HTML tags. Oh, don't trust me on that. Yep, yep, yep. Yep. No, let's do the maxi. Okay, good. Run. Nope. What you mean? Small heap is fair. Oh my God, the self keyword. Ah, it's killing me. Oh. Okay, I have to write it so I remember it. Pain, 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 pain. Oh, da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. Yay. No, okay. Heap push is not defined. What do you mean heap push is not defined? Oh my God, forgot to import. Heap q import heap push heap gpop. Love it. I love it. Nope. 7. 7 gonna go to the small heap. 5 gonna go to the small heap. 15 gonna go to the big heap. Get gonna return uh 10. 7 gonna go to the small heap. 5 gonna go to the small heap. 7 gonna go to the small heap. 5 gonna go to the small heap. Up, 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 up. What is going on? Implement a max heap, right? 7, 5. I mean, 5 is smaller than 7. So 5 gonna go into the small heap, 15 larger than 7. Go to the max heap, the mean heap, right? The mean heap, the mean heap. Get, it's gonna return 7. Why return 10? Okay. 1, gonna go to the small heap, return 7. Seven gonna go to the small heap. 5 gonna go to the small heap. 2 gonna go to the small heap. Get, return 7 divided by 2 is 3.5. 4 can also go to the small heap. The small heap, which is like 7. Where did I go wrong? I failed to handle one edge case. I failed to do the balancing. If length of max heap, when we say max heap, we say the small heap is larger than the the small heap is larger than big heap plus one, which is like illegal. We have to swap the value around. Oh my God. Oh, okay. I see. This is tricky. Okay, sure. Value of heap top, max heap push, mean heap, subtract value. Okay, so we have to give away one value. Like this value gonna go into the mean heap and be the new mean. Got it. Easy. Yay. What? Okay, okay. I messed up real bad on that one. Okay, syntax error. Crap. All right, good. Damn. Still fail 5. What? Why am I returning negative value now? Um, um, what's going on? What is going on? 8, 9. Okay, 8 go to small heap, 9 go to the big heap. Get, return. Um, if length of the big heap is 0, throw it into the into the small heap. That's weird logic. Why is it? I mean, it doesn't matter, right? We're gonna balance it anyway. Oh, I see. Let's try calling balance regardless of what. So I prioritize putting stuff into the big heap to the small heap regardless of if it's empty. Put stuff in it, not putting anything in the big heap when it's empty. Okay, so do not put stuff in the big heap when it's empty. Keep putting it in the mean heap, and then we start comparing from there. Okay, that's the moral of the lesson. Huh. why I shouldn't put stuff in the mean heap in the big heap when its length is 0, but I should put stuff in small heap when big heap length 0 and start comparing. Answering TA. Oh, I see. Okay, is violate a variant? Hmm. All right. Oh, yep. Thanks for watching, guys. This is the coded version of the prior main median of data stream, which is like a pretty hard problem. Okay. See you later. Thanks for watching.